This is a problem given in NEET 2016 concept of friction. Problem is like this. A car is negotiating a curved road of radius r. Road is banked at an angle theta. Coefficient of friction between tires and the car is mu. What is the maximum safe velocity of this car on this road is the question, right? Let us try to draw the diagram and understand what he has given for you. If the road is horizontal, it looks like this. But this road is not, it is inclined at an angle theta to the horizontal. On this road, now it is given that there is a car. This car will have definitely some mass. Obviously, its weight always acts in vertically downward direction, mg. Right? Now, it is moving in a circular path of this curved path, certain radius. Thus, there will be a frictional force acting towards the center of that circular path, who helps in providing a necessary centripetal force. So this is the direction of the frictional force. Now I can say that frictional force can be resolved into components. As this angle is theta, this angle also will be equal to theta. This will be the adjacent component of that frictional force, F cos theta, and the other component shall be perpendicular to that, this way, F sin theta. That's the frictional force acting. Now, as the body is having some weight and pushing the floor downward with an angle, that's an action, then there will be a reaction too. That reaction is called normal reaction, N. That N also can be resolved into components. As this angle is theta, this angle is also theta. Then this becomes adjacent component of that N cos theta. And the other component will be perpendicular to that, N sin theta. So once after identifying what all the forces acting on the system, you shall see them carefully and identify them so that you will be drawing the diagram again and you will be able to identify that. For the car to be safe, it shall be equilibrium. Fy upward must be Fy downward. What is the Fy upward acting is? Force acting in upward direction is N cos theta. What are the forces acting in downward direction is mg plus frictional force of sin theta. From here I can write an equation mg as n cos theta minus f sin theta. I'll be using this data further. That is when we are equating the equilibrium of the vertical forces. Not only just a second. Not only that, for balance, for equilibrium, not only the forces along y direction, forces along the left has to be forces along the right. What are the forces acting along the left is, yeah, you can see what is the forces acting along the left is n sin theta, this one, and f cos theta. These are the forces acting towards the left, right? These are the forces acting towards the left. Then they provide the necessary, they are being balanced by the centripetal force. So their combination must be equal to what? mv square by r. So these forces are acting like this. So mv square by r will be acting in balancing that, which is called centripetal force. You call this as equation number 2. You can do what we do now is divide equation number 2 by equation number 1. On the left hand side, mv square by r, first equation, and the second equation, that is mg, equal to on the right hand side n sin theta plus f cos theta by n cos theta minus f sin theta. M can be cancelled. V square by rg equal to n sin theta. Frictional force can be written like mu into normal reaction. Mu is given as mu s. N cos theta minus mu s into normal reaction of sin theta. So our normal reactions can be cancelled. So V square by Rg is sin theta plus mu s cos theta by cos theta minus mu s sin theta. But if you look at the answers, none of the answers are in terms of sin and cos, they are all in tan. So I shall convert this equation to tan. What I will do is, I will divide the entire numerator and denominator with cos theta, so that sin theta by cos theta becomes a tan theta and some cos theta gets cancelled, right? So what we need to do is divide all RHS with cos theta. What happens then? V square by Rg equal to sin theta by cos theta plus mu s cos theta by cos theta divided by cos theta by cos theta minus mu s sin theta by cos theta. What happens then? V square by Rg equal to sin theta by cos theta is tan theta plus mu s cos theta and cos theta will cancel. Here also in the denominator they will cancel. 1 minus mu s by sin theta by cos theta equal to tan theta. That is V square by Rg. So V square equal to Rg of tan theta plus mu s by 1 minus mu s tan theta. So V will be square root of Rg of tan theta plus mu s by 1 minus mu s tan theta is the answer for the problem. Look at the options, right? There is only one option available, that is this Rg of tan theta plus mu s by 1 minus mu s tan theta. That's how we solve the problem. So looks like a little lengthy problem for you, but you need to know the basic concepts, that how they are working, then only you will be able to answer this question. Lot of concepts are there, conceptual understanding is required. The first thing is frictional force acts in this direction, which is resolved into components. You need to understand that. The next thing is normal reaction acts in this direction, which is resolved into in these components. You need to understand that. Then, being a safe velocity at a given instant, it has to be equilibrium. Forces acting along y direction has to be balanced. Forces acting along x direction also has to be balanced. So be careful in understanding that n sin theta and f cos theta are acting this way. So the centripetal force must be acting this way, mv square by r. As I have balanced all of them and simply divided and simplified, I got the answer. Mathematical calculation shall not be a problem. Only thing first you need to understand is how are you getting there into conceptually. That point you get it carefully so that you will be able to get it right, able to understand it. Thank you for watching.